All right, so in 4.6, we're going to continue with differentiation. So we're going to use a lot of the same strategies that we've learned throughout chapter 4. So product rule, chain rule, quotient rule, all of that stuff. We're just continuing to take the derivative. So we're going to find related rates. So to do that, we take the derivative, and then we're going to use related rates to solve real life problems. So a lot of these questions in 4.6 are going to be word problems. So when we find related rates, we use the chain rule to find the rates of change of two or more related variables that are changing with respect to time. So in our questions, we're going to have x's and y's or different variables depending on what the question is. And when we take the derivative, we have to take the derivative with respect to time. So if I took the derivative of x, my derivative would be dx over dt. So with respect to time, we got to put that dt. So any variable that we take the derivative of, we have to make sure we include the dt on the bottom. So for example, when the water is drained out of a conical tank, the volume, the radius, and the height of the water level are all functions of time. So knowing that these variables are related by the equation, so our volume for a cone would be pi over 3 r squared times height. You can differentiate implicitly with respect to t to obtain the related rate equation. So if I took the derivative of this, we'd have to take the derivative of each variable with respect to t. So the derivative of v would be dv over dt is equal to, that pi over 3 is just our coefficient, so I'm going to leave that out front. And then we have r squared times h. How would I take the derivative of r squared times h? Product rule. We're multiplying r squared times h, so I have to do the product rule. So the first would be r squared times the derivative of the second. What's the derivative of h? 1, but what do we have to make sure we include? dh over dt, since h is our variable. Plus the second, which is h, times the derivative of the first. What's the derivative of r squared? 2r, but what do we have to remember to include? dr over dt. Perfect. So any variable that we take the derivative of, you have to make sure you include the either dv over dt, dh over dt, or dr over dt. So don't forget that, because that's going to be part of your question. So then from here, the question's usually going to give us things to plug in. We just plug them in and solve. So the hardest part for these types of questions is finding the derivative. So example 1 says, suppose x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. Find dy over dt when x equals 1, given that dx over dt is equal to 2 when x equals 1. So let's find the derivative. So we're going to take the derivative of y equals x squared plus 3. So what's the derivative of y? dy over dt, perfect, is equal to, what's the derivative of x squared? Awesome, 2x times dx dt. All right, so then once we take the derivative, the question's asking us to find dy over dt, so we don't know what that is yet, given that dx over dt is equal to 2 when x equals 1. So from here, we're just going to plug everything in. So dy over dt is equal to 2 times, what do I plug in for x? 1. And what do I plug in for dx over dt? 2. So dy over dt is equal to 4. Let's do the same thing for example 2. So we're going to take the derivative here. We want to find dy over dt when x equals 2, given that dx over dt is 4 when x equals 2. So let's find our derivative. What's the derivative of y? dy over dt. What's the derivative of x cubed? 3x squared dx over dt. Plus 4, what's the derivative of 4? 0. So we have that dx over dt is equal to 4 and x equals 2. So we're going to plug those in. So dy over dt is equal to 3. What do we plug in for x? So 2 gets plugged into x, and what's dx over dt? 4. So from here we have 3 times 2 squared would be 4 times 4. So 12 times 4 would be 48. Awesome. Most of the questions in 4.6 are going to be word problems, so they're going to be similar to the next couple examples. So example 3 says a pebble is dropped into a calm pond causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 3 feet per second. When the radius is 30 feet, at what rate is the total area A of the disturbed water changing? So what's the shape that we have here? A circle. It's asking us for the area of the circle. How is the area changing? So what's the area of a circle formula? Pi r squared. Awesome. 2 pi r would be the circumference. So pi r squared. So let's take the derivative. What's the derivative of A? dA over dt, perfect, is equal to, here, is pi a variable? No, pi is a constant. So that's just a constant out front. What's the derivative of pi r squared? 2 pi r dr over dt. So just think about that pi as a constant out front. If I had 4r squared, we'd multiply the 4 times the 2. So now let's plug in what we have. So the radius of the outer ripple is increasing at a constant rate of 3 feet per second. When the radius is 30 feet, at what rate is the total area changing? So 3 feet per second is what? What is 3? What am I plugging 3 into? Awesome. 3 is dr over dt, because that's how the radius is changing. It also, you can look at your units to kind of help you. If it was just 3 feet, that would be our r. But since it's 3 feet per second, this is how it's changing with respect to time. So that's why it's dr over dt. So use the units to help you. So it says when the radius is 30 feet, so what am I plugging 30 into? R. Awesome. It says what is the rate at what rate is the total area of the disturbed water changing? So we're looking for what our area is changing, or what is the area that's changing. So we're looking for dA over dt. So let's plug in what we have. dA over dt is equal to 2 pi, what's r? 30. What's dr over dt? 3. So dA over dt would be 30 times 3 is 90, times 2, 180 pi. 180 pi what? But it's how the area is changing. So it's not just feet per second, feet squared per second. So since it's the area, it's feet squared per second, or feet per second squared. Next page, we have guidelines for solving related rates. So it's just what we did. Find or identify the given quantities and quantities to be determined. So read the question, figure out what it's giving you and what it's looking for. You want to take the derivative, but don't forget to differentiate all the variables with respect to time. and then substitute in everything that you have and solve. Here's some examples of rate of change. They're not really questions, but in the first one it says the velocity of a car after traveling for 1 hour is 50 miles per hour. So 1 hour would be the time. 1 would be time. 50 would be what's changing. So that would be dx over dt. So 50 is the amount of miles or the distance traveled with respect to time. So these are just kind of examples that you may see. Let's look at example 4. Air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 2 feet. So what shape do we have here? We have a sphere. Spherical balloon. So the volume, we're talking about how much air is in the balloon. So the volume of a sphere would be 4/3 pi r cubed. Any equation that we have, so right now we have the area of a circle, the volume of a sphere. Anything that we do is going to be fair game for the quiz. So I would keep a list of all the formulas that you use. I'm not going to quiz you on something that we haven't gone over, but now we've gone over area and volume of a sphere. So keep a list of all the formulas that we've done throughout the notes and throughout your web assign. Make a list of those so you study them. Formulas are not going to be given to you. But I'm not going to quiz you on something that we haven't done. So we have our volume of a sphere.
Is it cubed or squared?
Cubed. Volume is cubed. So air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. So we've got 4.5 cubic feet per minute. Find the rate of change of the radius. So we're looking for the rate of change of the radius when the radius is 2 feet. So I would recommend finding the derivative to see what the variables you have are, and then figure out what's what. So figure out what are we plugging 2 into, what are we plugging 4.5 into. So let's take our derivative first. What's the derivative of v? dv over dt is equal to, now 4/3 and pi are just our coefficient. So that just stays the same. 4/3 pi. What's the derivative of r cubed? 3r squared dr over dt, perfect. We can simplify this a little bit since we're multiplying by 3 and dividing by 3, so those cancel. So dv over dt is equal to 4 pi r squared dr over dt. So we have 4.5. 4.5 is going to get plugged into what? Be careful. 4.5 is cubic feet per minute. So, and it's the rate at which the volume's changing of the sphere. So 4.5 is going to be dv over dt. A key word here, or a clue, is cubic feet per minute. So the volume is cubed. So cubic feet per minute is dv over dt. And then we're looking for, asked us to find us the rate of change of the radius. So rate of change of the radius is how the radius is changing. So that's dr over dt. That's what we need to figure out. That's what the question's asking us for. And then it says the radius is 2 feet. So what's 2? R. Perfect. Let's plug in. So 4.5 is equal to 4 pi, 2 is getting plugged into the radius, so 2 squared times dr over dt. That we don't know yet. So we have 4.5 is equal to 2 squared. would be 4, and 4 times 4 is 16 pi dr over dt. How would I get dr over dt all by itself? Divide by 16 pi, perfect. So here we have 4.5 over 16 pi is equal to dr over dt. I haven't made the quiz yet for Friday, but I'll most likely let you guys use the scientific calculator again. So this you would just plug into the calculator. On the WebAssign, there's questions like this where it wants decimals, so just plug it into the calculator to find your answer. But one last step, let's figure out our units. What unit are we talking about here? Feet per minute, awesome. So use the question to help you. It says feet per minute here. So feet per minute. If it was just talking about length or the radius, our radius would be feet here. If it was talking about area, our area is feet squared. Or if it was talking about the change in area, it'd be feet squared per minute or per second, whatever the unit is. And then if it's talking about volume, it'd be feet cubed.